Okay, today we're going to look at some more equations of circles and graph them, and then use equations to solve some application problems. So let's talk about graphing them first. So here's our first example, and notice there's no parentheses here, so that means your center is going to be at 0, 0. And then this number is your radius squared. So radius squared is 25, which means your radius is 5. Now, again, you don't have to do this step every single time. I will, just so we can see what's going on. So the way I graph these is I start from the center, and I go 5 in each direction, horizontally and vertically. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then I make the best circle I can. So just try your best on that. Obviously don't make something like that. You're not even trying at that point. So that's all you got to do. Okay, so the center of this circle is going to be 2, negative 1. So the opposite of what you see here. So positive 2, 1. There's your center. Then this 16 is the radius squared. Take the square root of 16, you get 4. So then I'm going to go 4 in every direction. And that's how this circle will look. The center is at, again, 2, negative 1. Then example C, okay, there's no pluses or minuses or parentheses with the x, so this x coordinate of the center will be 0, negative 2, because we see plus 2 in our parentheses. So there's our center. Now r squared is equal to 1. Well, the square root of 1 is just 1. So I'll go 1 in each direction, and then I do my little circle and try to do the best you can with that. Okay, so graphing them isn't too bad. Now here, we're going to use the given information to write the standard equation of the circle. Remember that the general form of an equation of a circle is x minus h squared plus y minus k squared equals r squared, where h and k are the center, and x and y are points on the graph, and r is your radius. Well, we need to figure out the radius here. We know that the center is at 0, 0, and we know that the point 0, 4 is on the graph. So what I'm going to do is I'm going to plug in these values. Since the center is 0, 0, I'm going to plug that in for h and k, and plug in 0, 4 for x and y, because then I can simplify that to figure out what the radius is. So it's going to be, instead of x, I'm going to write in 0 minus h, which is 0 squared, plus y is 4, minus k, which is 0 squared, equals r squared. So 0 minus 0 is 0, and then 4 minus 0 is 4. So 4 squared equals r squared. Now, yes, you can simplify this and say, like, okay, well, square root both sides, and we get 4 equals r. That's okay. Or you can just leave it in terms of r squared. This is probably a better idea. So I know my radius is 4. Now I have my radius, I have the center of a circle, so I can do what we did yesterday. So x squared plus y squared equals 4 squared, or 16. And that's the equation of the circle. It's kind of hard to see this actually when you are dealing with a center at 0, 0. So in letter B, we will see this probably easier. So again, the equation of a circle and we need to figure out what the radius is. Now, you could say, well, can't we just do the distance formula between the center and the point on the circle to get the radius? Yes, you can do that, but I know how much you guys despise the distance formula. So I come up with another way that will hopefully make things a little bit easier. So we need to plug in our values. X and y come from the point on the circle, and h and k are the centers of the circle. So now I can substitute my values. -1 minus 3 squared, because x is -1, h is 3, and we have a subtraction sign there, plus y is 2, minus -3 squared equals r squared. 1 minus 3 is -4 squared, plus 2 minus -3 is +5 squared equals r squared. -4 squared is 16 plus 25 equals r squared. So you may be saying in the other problem, why did I not make this 4 squared? The reason why I didn't do that was because I only had one number here. It was just 4. I didn't have anything from this part. That's why I said it might be easier to see when our center is not at 0, 0. So now 16 plus 25 is 41, and that equals r squared. Well, I'm not going to take the square root of this, because r squared is 41. That's what we need in our equation, is r squared. So now I'm going to write my equation, x minus h, so 3 squared, plus y minus k, again k is -3, so it's going to be plus 3 squared, equals, in r squared, we've calculated that to be 41. And that's your answer. All right, let's look at letters C and D. Now we have the endpoints of the diameter. Remember, the diameter goes from one side of the circle to the other, but also goes through the center of the circle. So if we find the midpoint of a diameter, that will give us the center of the circle. So first thing we're going to do is we're going to find the midpoint, which will be the center of our circle. So calculate the midpoint of our diameter. You're going to add the two x coordinates and divide by 2, comma, adding the two y coordinates and dividing by 2. So 1 plus 5 is 6, divided by 2 is 3. 6 plus -2 is 4, divided by 2 is 2. So that's our center. So this is our h and k. Well, now this is kind of like the problems from up here, where we have the center and we have a point. Well, which point do you use? It doesn't matter which one. I like to use the points that are both positive numbers. It makes things easier. So x, there's your x comma y. So our equation of the circle is x, 1 minus h, which is 3 squared, plus y 6 minus 2 squared equals r squared. Again, I'm just using this equation right here and plugging in my x, y, h, and k values. So 1 minus 3 is negative 2. Negative 2 squared is 4. Plus 6 minus 2 is 4. 4 squared is 16. That equals r squared. 4 plus 16 is 20. So 20 equals r squared. Well, now I have my center right here, and I have my r squared value. So now I can write the equation of my circle. Alright, so I want you to pause the video and try part D and see how you do. Alright, let's see how you did. So first you want to find the midpoint of these 2 points because you want to find the middle of the diameter. That will be the center of your circle. So negative 3 plus 11 over 2, adding the x coordinates. Then you want to add the y coordinates and divide by 2. So the center of the circle will be, let's see, the x coordinate negative 3 plus 11 is 8. 8 divided by 2 is 4. And 4 plus negative 8 is negative 4 divided by 2 is negative 2. So there's your center. There is your h and k value. Now I look at the points that I was given up here, and they both have a negative value. So I can't use what I did in the other problem and try to avoid using negative numbers. Here we're going to have to. So it doesn't matter which one you use, we'll get the same answer. So then it's going to be x, which is 11, minus 4, which is our h value, squared, plus y, well, y is negative 8, minus our k, minus negative 2, squared, equals r squared. 11 minus 4 is 7, so 7 squared, plus negative 8 minus negative 2. It's really negative 8 plus 2, so negative 6 squared equals r squared. 7 squared is 49, plus negative 6 squared is 36, and that equals r squared. 49 plus 36, that is going to be 85. So 85 equals r squared. Now we can write the equation of our circle, x minus 4, because that is our h value, squared, plus y minus negative 2, because negative 2 is our k value. So minus negative 2 will be plus 2 squared equals, our radius squared from right here, 85. And that is our answer. Alright, now let's look at the next page. You may see that these problems are spaced out a lot, or that we use 3 pages, and it's just I want to give you guys enough space to write these and not have to write super small. I don't like to write super small, and I'm a messy writer, so I like to give myself a lot of space, so that in turn gives you guys a lot of space. So example 3 says, does this point lie on the circle centered at the origin and contain the point 0, 2? Okay, so if our circle is centered at the origin, that means my h and k value is 0, 0. Like, that's the center. And if this is a point on the circle, so my point is 0, 2. Okay, how can we write the equation of the circle from this information? And this one is a little bit easier because our center is at 0, 0, and the point they give us is 0, 2. Because the two x coordinates are the same, that means that this is a vertical line. Let me show you what I'm talking about. If we plot this, and we have 0, 0, and the point on the circle is 0, 2. Well, we can count that and say, oh, the radius is 2. We're going up 2. So the r is 2. So we have our center, 0, 0, and we have our radius. We can then write the equation of the circle. Because our h and k are 0, normally we would do x minus our h value, 0 squared, plus y minus k is 0, equals r squared, in this case 4. Well, remember, we don't have to write minus 0. So anytime that our center is 0, 0, we're not going to write minus 0 in our equation. So now we have x squared plus y squared equals, oops, it should not be 4 squared, it should be 2 squared, which is 4. And now we can plug in these points. At this point, 1 squared, because that's our x value, plus the square root of 3 squared equals 4. Is this a true statement? Well, 1 squared is 1, plus the square root and second power cancel, so 4 equals 4. Yes, this point does lie on the circle. Okay, the circle. Now, a real-life application to this is in example 4, where we have our cell phone tower. A lot of you think that we have not very good cell service inside our building. So this is kind of how cell phone towers work. They have a center where the tower is, and then they broadcast in all directions. So they create like a circular field of where the signal goes. Now, what we're going to do here is we're going to read the problem and use that knowledge to see if the signal is strong enough. So the plotted location of a cellular phone tower on a coordinate grid is -3, 2. So that's our center. And the range is 5 units. So that's our radius, because I can go 5 units in every direction. Write an equation that describes the position and range of the tower. Okay, so that's going to be x plus 3 squared plus y minus 2 squared equals r squared 25. If your home is located at 1, 5, do you receive service from the tower? And then your friend's house is at -6, 5, does she receive service? So what we're going to do is we're going to plug these points in. We'll start with this one first for x and y, and see if we get a number smaller than 25, equal to 25, or bigger than 25. If we get a number smaller than 25, that means we are inside the circle. So let's plug that in. So it's going to be 1 plus 3 squared plus 5 minus 2 squared equals 25. 1 plus 3 is 4. 4 squared is 16. Plus 5 minus 2 is 3. 3 squared is 9. That equals, and then we say that equals 25. 16 plus 9 is 25. And 25 is equal to 25, so yes, you would get service. It may not be the best service since you're at the very edge of that circle. So yes, you get service. Now your friend at negative 6 comma 5, we're going to plug that in for x and y. So negative 6 plus 3 squared plus 5 minus 2 squared equals 25. Negative 6 minus 3, negative 6 plus 3 is negative 3 squared. So this part will equal 9 plus 5 minus 2, just like what we had over here, be 9 once we square it. So we get 18 equals 25. Well, obviously 18 is not equal to 25. 18 is smaller than 25, so your friend would get signal. And probably better than you, since over here we're right on the end of the circle, and over here we're inside the circle. Now if we would have gotten a number like 29 or 30 or anything bigger than 25, we would not get service. So yes, she gets service. And that is because 18 is less than 25. Alright, so example 5 kind of summarizes everything that we've done with circles so far. So let's get at it. It says, every July 4th, Boston puts on a gala with a Boston Pops Orchestra, followed by a huge firework display. There is an explosion circle inside, which all the fireworks will explode. Spectators sit outside a concentric safety circle that is 800 feet from the center of the firework display. So this term, cocentric, what that means is that the circle has the same center. 2 circles or 3 circles have the same center. So what we have here is we have a circle here. This is where the firework display happens. That's the explosion circle. And then outside that we have the safety circle. And these circles have the same center. And they're telling us that the radius of the safety circle is 800 feet. So part A says find the approximate circumference of the safety circle. So remember, circumference equals 2 pi r. So then the circumference will be 2 times pi times 800. So we type that into the calculator. It doesn't say to give exact values, so we can round and get that the circumference is 5,026.55 feet. Now, letter B says if the safety circle is 200 feet farther from the center than the explosion circle, find the equation of the explosion and safety circles. So the safety circle is 200 feet further out. So that means that the radius of the explosion circle is 600 feet. And we know that because the radius of the safety circle is 800, and that 800 is 200 feet further out. So this distance right here is 200 feet. It's 200 feet further than the explosion circle. And if that's the case, 800 minus 200 gives us 600. So let's write the equations of each circle. The safety one. Now, they're not telling us anything about a center and all that, so let's just make the center easy to work with, 0, 0. So we can do x squared plus y squared equals 800 squared. Okay. Then we can simplify that. I'm going to do 800 squared in the calculator. X squared plus y squared equals 640,000. Now for the explosion, the same center, x squared plus y squared equals, and we can do 600 squared to get 36,000. Alright, so those are the two equations of circles that we're going to use. Next page, it says the organizer spray the ground inside the explosion circle with a fire retardant. Each gallon covers 1,000 square feet and costs $50. How much does it cost to protect the space? So we need to find the area of the explosion circle. Area equals pi r squared. We know the radius of the explosion circle was 600. So if we type that into the calculator, we get a honking big number. The area is 1130973.36 feet. So that's how much area we have to cover, and each gallon covers 1,000 square feet. So we're going to take that big number and divide that by 1,000. This gives us 1,130.97 gallons that we'll need. Now each of those gallons costs $50. So we're going to take that number, the number of gallons we need, and multiply it by 50. And then that will give us, in dollars, $56,548.50. So that's how much it will cost to protect the explosion circle from catching on fire from these fireworks. Now, letter D, a small shed is located at a point that is 550 feet west and 225 feet north of the center of the explosion circle. Is the shed in danger? So we got to figure out how do we deal with these distances right here. If we look at a compass, we have north, east, south, and west. So when it says that we are 550 feet west, that means that's going in the left direction. So the x-coordinate would be negative 550. It says 225 feet north, okay? That's going up, so that's the y direction of positive 225. We're going to plug these values in. Our point's going to be negative 550, comma 225. We're going to plug this in to the explosion circle equation and see if the circle, or if this point is inside or outside the circle, kind of like the cell phone tower problem. So the explosion circle equation is this one up here. X squared plus y squared equals 360,000. So in my calculator, I'm going to do negative 550 squared plus 225 squared equals 36,000. So I'm going to type this part in my calculator. And when I do that, I get 353,125. Well, this is not true. The left side here This left side is smaller. So that means that the shed is inside the circle, and it's in danger. Okay, so yes, the shed is in danger. Alright, now the last part. You are sitting 700 feet east. Okay, so again, if we look at our compass, east is a horizontal direction. So this tells us that our x-coordinate of our point is positive 700, and then 375 feet south, so that's going down. So negative 375. So that is our point. So that's where we're sitting. Where are you in relation to the two circles? So are we inside the explosion circle, in the safety zone, or even outside the safety zone? And in order to do this, I'm going to use the safety equation, because that circle is the biggest. Because if I know if I'm outside of that, then I got to be outside the explosion circle as well. So we'll type this into the calculator. 700 squared plus negative 375 squared equals 640,000. So again, I'm going to type this left side into the calculator. We get 700 squared plus, so I get on the left side 630,625. Okay, so that is less than 640,000. So I am outside, or sorry, I'm inside the safety circle. So inside the safety circle, but am I also inside the explosion one? Well, the explosion circle is 360,000. This number here is bigger than that, so I'm outside the explosion circle. And outside. So I am okay, we're safe, we're watching the fireworks, we're having a good time. So, like I said, this problem, all the parts of it really summarize everything we've done so far, except the graphing equations part. That's the only part that this problem really didn't touch on. So this would be a good one to review and make sure you really understand what we did and, more importantly, why we did it. So as always, reach out if you have any questions, and I will see you all later. Bye.